Today we're going to be graphing logarithms, and we're going to be doing it mostly from the transformations perspective. On the test, the graphing component is going to be bonus. Everything else is going to be done just like the last test, where you have to identify each of the transformations. Just like an exponential, this number here is going to fluctuate based the base, which is the same as the base in the exponential, fluctuates. And that tells us a lot of details, but each one has its parent function of whatever that base is. So the parent function of this one is log base 4. And I'm going to tell you how to find each of the transformations. These are going to have vertical asymptotes versus horizontal asymptotes. These are the inverses of exponential. So the domain is going to be similar to the range on exponential. The range is going to be similar to the domain. So in all of the logs that are not reflected, the domain is going to be restricted. That means it's going to be either greater than or less than a certain number. And the range is going to be all reals. This will be our first time we've ever had the domain restricted, but not the range. And so, first off, to find your vertical asymptote, it is going to be x equals what the opposite of whatever that number is, so just the h. So if I have, and we'll go through with numbers in these to see the pieces. We are going to move left / right based upon the h. Left is going to be when it is positive, and right is going to be when it's negative. You're going to move up / down, up, positive, down, negative, based upon the k. This a, if it's greater than 1, is a stretch. Less than 1, compression. For all the problems I gave you today, I didn't actually give you an A, but I want to go ahead and introduce that so that you know where those numbers are coming from. And to find the x-intercept, you replace y with 0 and solve. We are not going to be required to find the y-intercept on any of the problems today. We're actually finding the x-intercept each time. So if I give you the equation, y equals log base 4 of x plus 2 minus 3. So we're going to go through and we're going to identify each piece that we can find. So first off, did I move up or down? How much? So I moved down 3. Did I move left or right? And how much? What opposite? So left 2. So where is my vertical asymptote, and I will abbreviate that as VA, going to be? It's going to be x equals the opposite of this. So negative 2. So I'm going to go ahead and graph that in here. At negative 2, we are going to have a vertical asymptote. So if I was to try to find my x-intercept, I will replace y with 0 and then solve. So to solve this, I need to get my logarithm by itself because there's only one log. So add 3 to both sides. So 3 equals log base 4 of x plus 2. Then I'm going to fish it. And so this is going to be a backwards fish because I have it on opposite sides. And so 4 to the third is equal to x plus 2. And so x is equal to 4/3 minus 2 when I move this minus 2 over. 4/3 is what? 64 minus 2. So that's going to give us 62 as that answer. So our x-intercept is going to be 62, 0. Often your intercepts are not always going to be able to be graphed based upon the numbers. It's okay. You just have to identify it. You may not actually be able to fit it on the graph. So now, let's open up your graphing calculator and go to your graphing utility. Y equals, type in this logarithm. It can either be f of x equals or y equals. Either one is okay. Using your table of values is going to help you find some coordinates that you can actually graph. And so you should have seen at -1 is at -3. And so you can plot that point.
Control T.
Control T pulls up the table.
Oh, yes.
And that will make it easy. You can use the trace feature and trace along the line, but the table is easier to find specific values that work. Another spot that you should have been able to see that crosses perfectly is at -2. And then you'll start noticing that it's not, and I think the next one that you have as a table of values that will cross through perfectly is going to be at 13, -1. And so that's off my graph. And so the sketch, is it 14?
Or there's 6, -1.5.
Okay, you could have used that, the 6, -1.5, because that's something you can find the points of. But you'll be able to find a few points where you can plot using your table. I am not going to make you go through and find values by using just a traditional plug and play. Logarithms are too hard to do that. You will use your tables to help you find the graphing components. So what I will be looking for is I'm going to be looking for if you placed your asymptote correctly and a couple of points along the way. And so you see how in this graph, if you keep going, it takes a while before you actually get to where it crosses the x-intercept. It will eventually, but it does take a while. If you keep tracing out towards the right-hand side, you'll see that. So the last thing that we're going to do, before we go on to the next problem, is identify a domain and range. So domain, am I going to go through all my x's? No. Am I going to be greater than or less than a certain value? greater than -2. Range, am I eventually going to cover all my y's? It's going to crawl up very slowly to get up to the positives, but eventually I will go through all of them. And so it is all reals. So on your homework assignment, you'll be asked to identify up and down transformation, left and right transformation, vertical asymptote, x-intercept, domain and range, and graph. That's it. You will only have 10 problems. So, I know these are long steps, and I'll do one more with y'all. Y equals log of 1/2, base 1/2 of x minus 3 plus 5. So, left/right. Did I have any transformations that moved me left or right? Right 3. Based upon this number. Because remember, it's opposite. And you'll notice, if you've noticed for the whole year, anytime we have any operations inside and we're looking for the transformation, it's always opposite. Because inside the parentheses or inside the operation, it's always opposite. Up/down.
Up 5?
Up 5. Vertical asymptote.
X equals 3.
X equals,
No.
no, 3. It's opposite. And so let's go ahead and graph that. I'm doing this as a solid line so it shows up a little bit better, but usually you graph that with a dashed line. Okay, and so the next thing we found was our x-intercept, correct? And so x-intercept is when I replace the y with 0. And then we're going to do some transformations. To solve it. So we need to get the log by itself. Oops, not plus 5, minus 5.
Wait, why is it?
Because it's added, so I need to subtract. So -5 equals log base 1/2 of x minus 3. And then I'm going to fish it to solve it. So 1/2 to the -5th equals x minus 3. So if you don't know what 1/2 to the -5th is, use your calculator to help you find it. And I'm running out of room to keep going down, so I'm going to write it to the side. That's 32. If I'm remembering correct, I remember the number correctly.
Yes.
Equals x minus 3. Now I would add 3. And so x equals 35. So my x-intercept is 35, 0. So you know how I notice this all for x? That tells me what I'm replacing with the 35. Because I replaced y with 0, that's the reason this is 0. So if you have troubles trying to see which one's 0, which one's the number, think about what letters you replaced or what letters you're solving for. And so this is again where we're going to use our graphing calculator, and we're going to graph it and help us get a table of values. Similar to how your base being greater than 1 and your base being less than 1 changed how your graph looks. When your graph, same thing here. We have less than 1 for our base of our logarithm. What's different about how our logarithm looks when you see the graph?
It's up there.
It's up at the top part, not down at the bottom part, right? And that's the way it's going to be. Okay, so let's find some values that we could actually graph. So what's the first table on the table that you see that you can plot a point of that's easily to plot? 4 or 5?
5, 4.
So 4,
6.234.
you can do 6 point, what was it, 2, 3, 4?
6 and then 3.41503 and keep going.
Yeah, and so it's kind of hard to graph that one, right? How about at 4? Isn't 4?
4 and 5
Oh, that's right, we already got that one. How about 5?
and 4.
And at 7, we're at 3. At, or, did graph it at 6, didn't I? That's supposed to be at 7. And I think that's the only one that will show up on this graph that I provided. And so then you're just going to sketch in what the graph will look like for the rest. And like I said, I'm looking for the key points that can be graphed in the graphing window I provide. So the other thing that we haven't covered yet is our domain and range. So domain, are we restricted? Are we going to go through all our x's?
Probably.
No, because we have that asymptote that's stopping us from going too far left. So we're going to go x is greater than, is it 3?
Yes.
Okay. And our range, are we eventually going to cover all the y's? If you keep scrolling to the left, it's going to eventually, very slowly, crawl down into the negative y's. But it will, if you get a big enough x in, go down into the negatives. So this will be all reals.